Of the organic plant residues added, there were 3 of different carbon to nitrogen ratios applied with different timing throughout the year rather than all at once. So mowed living mulch basically throughout the year, leaving habitat at least 30% unmowed at any one time. Chipped branches from tree prunings over there on the right, you can see the chipped branches, and then continuing with the off-farm yard waste compost. Approximately 2 to 4 tons per acre mowed hay mulch dry weight added to the soil per year. You can see actually there's quite a bit of a hay crop being put down there, and look how tall the living mulch had gotten in between the trees. We started allowing it to get pretty wild later on. So then the second thing is high carbon prune branches with high nitrogen leaves added to the soil from 1 to 2 tree prunings per year. So you can see at his feet there are some pretty green branches from that pruning in late summer. And remember I said that he went through with the mower and mowed those branches in, and then by the time I was there, a couple of weeks later, you could hardly find any big branches. Amazing stuff, just amazing. Obviously wasn't like that in the early years. Let me move on to the last carbon material, the composted yard waste, added 1 to 2 times per year at 2 tons per acre each application. So you can see it being applied. You can see what the pile looks like. And if you look to the left over all those lovely spring blooming weeds in the living mulch, if you look closely, you can see about the rate that ends up on the soil with at 2 tons per acre. It's a relatively light amount, but still 1 to 2 times every year. Carl stopped doing it on the apples when I showed up because I said, Carl, I'm pruning the apples, 4 inches of new growth 4 foot of new growth is too much. It does not need the compost. And then it kind of needed that discussion for him to be brave enough to say, okay, I'll stop. Of course, now on the new farm, we don't do any of it. So tillage only when taking the orchard out and moving to vegetable crops for a year or 2 before you add new trees. And I wanted to show you what happened with the nitrogen. So in 1982, the nitrogen was pretty low. That big jump up in the late 90s is where he added, he experimented with adding manure fertilizer in one field. And that's field 2. That's the lower field where he also had vegetables, or started out with vegetables. And you can see that huge jump where he added kind of a composted manure, but not a solid, really finished compost, but composted manure. And then after 1992, no more of that. And you can see that the nitrogen levels kind of went up, but never got really very high. But the organic nitrogen, and this was in 2014 when we were still trying to figure out a better way to look at nitrogen and carbon dynamics in our no-till, high residue, high carbon fertilizer system. So we experimented with some other ways to measure organic nitrogen, and we looked at the fields that were low in soluble nitrate nitrogen, but were much higher in this total Keldol nitrogen, which is just another way of measuring organic nitrogen, or a more organic form of nitrogen. So we also did leaf tissue analysis. On this graph, the blue line is 2014 when I took new samples, tissue samples, And the gold is 1994, and the black is what you would expect. What University of California says should be, what nitrogen level should be in the leaf tissue. So we had low soil nitrate nitrogen, we had relatively high organic nitrogen, and the tissue nitrogen had significantly increased as the nitrogen percent in the tissue, in the leaf, and was actually, how does this happen, higher than the sufficiency range that the University of California. So even though we didn't have much nitrate nitrogen in the soil, the nitrogen in the foliage was quite good by 2014. In 1994, it was still not particularly high. It wasn't terrible, but it wasn't in a sufficiency range.